In mathematics, a unit circle is a circle with a radius of 1. Frequently, especially in trigonometry, the unit circle is the circle of radius 1 centered at the origin in the Cartesian coordinate system in the Euclidean plane. The unit circle is often denoted S1. The generalization to higher dimensions is the unit sphere. If is a point on the unit circle's circumference, then x and y are the lengths of the legs of a right triangle whose hypotenuse has length 1. Thus, by the Pythagorean theorem, x and y satisfy the equation since x squared equals squared for all x. And since the reflection of any point on the unit circle about the x or y axis is also on the unit circle, the above equation holds for all points on the unit circle, not only those in the first quadrant. The interior of the unit circle is called the open unit disk, while the interior of the unit circle combined with the unit circle itself is called the closed unit disk. One may also use other notions of distance to define other unit circles, such as the Riemannian circle. See the article on mathematical norms for additional examples. In the complex plane, the unit circle can be considered as the unit complex numbers, i.e., the set of complex numbers z of the form for all t. This relation is Euler's formula. In quantum mechanics, this is referred to as phase factor. Trigonometric functions on the unit circle. The trigonometric functions cosine and sine of angle t may be defined on the unit circle as follows. If is a point on the unit circle, and if the ray from the origin to makes an angle t from the positive x-axis, then the equation x2 plus y2 equals 1 gives the relation. The unit circle also demonstrates that sine and cosine are periodic functions, with the identities for any integer k. Triangles constructed on the unit circle can also be used to illustrate the periodicity of the trigonometric functions. First, construct a radius OA from the origin to a point P on the unit circle such that an angle t with 0 less than t less than pi 2 is formed with the positive arm of the x-axis. Now consider a point Q and line segments PQOQ. The result is a right triangle delta OPQ with QOP equals t. Because PQ has length y1, OQ length x1, and OA length 1, sin equals y1 and cos equals x1. Having established these equivalences, take another radius or from the origin to a point R on the circle such that the same angle t is formed with the negative arm of the x-axis. Now consider a point S and line segments RSOS. The result is a right triangle delta ORS with SOR equals t. It can hence be seen that, because ROQ equals pi minus t, R is at sin, in the same way that P is at sin. The conclusion is that, since is the same as sin, and is the same as sin, it is true that sin equals sin and minus cos equals cos. It may be inferred in a similar manner that tan equals minus tan, since tan equals y1, x1 and tan equals y1. A simple demonstration of the above can be seen in the equality sin equals 1, sqrt. When working with right triangles, sine, cosine, and other trigonometric functions only makes sense for angle measures more than 0 and less than pi 2. In fact, all 6 standard trigonometric functions, sine, cosine, tangent, cotangent, secant, and cosecant, as well as archaic functions like cosine and x-secant, can be defined geometrically in terms of a unit circle, as shown at right. Using the unit circle, the values of any trigonometric function for many angles other than those labeled can be calculated without the use of a calculator by using the sum and difference formulas. Circle group. Complex numbers can be identified with points in the Euclidean plane, namely the number a plus by is identified with the point. Under this identification, the unit circle is a group under multiplication, called the circle group. On the plane, multiplication by gives a counterclockwise rotation by theta. This group has important applications in mathematics and science. Complex dynamics. Julia set of discrete nonlinear dynamical system with evolution function is a unit circle. It is a simplest case, so it is widely used in study of dynamical systems.